Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hello, I'm Nick.
Hey, I'm John.
And you can hear I got to get the guys back together. And you won't have to hear me just talking to myself again. Some of y'all I know are jumping with joy from hearing that note. Last week I kind of covered, what is STEM and kind of why we're passionate about it. Trying to, give the backstory on, what it is and why we do what we do. I don't know if y'all want to touch on that or what.
Well, I'll just do a quick. For me, it's going to be really quick. I mean, when they got real educational, they had to create STEM. And that's why you got a big gap in some of the, I would say, technical applications that are out there that are not being filled. Mm-hmm. So for me, that's why it's important to do STEM.
Yeah, it's vital. It's because we have a bit of a gap. I mean, just going to school doesn't make you smart, right? Just attending, just showing up, it's a step one. But like having a focus to grow the community starting earlier with STEM is the focus that we need, because right now it's hard because you wait till you're 18 to decide what you want to do with your life. You want to go to this college, you want to do military, you want to do a job, trade school, whatever the case may be. If you're not able to see what the other side feels like or how everything looks, you can't really make a decision. So we got to at least provide opportunity in that side. And honestly, the progression of STEM and how well it does in not just the U.S. but the world very much depends on how those programs do. So we should have the utmost focus on it and the highest level of expectations out of the STEM schools. But I've noticed we do have STEM magnet schools. There's a whole bunch of these things that are in place to develop this type of learning. But I think we should, as a curriculum and as an education system, I think it needs to be made a huge point that STEM needs to be at the forefront, not these other prerequisites and making everybody read the same or memorize the same Hamlet poem or monologue and having them recite it word for word. That kid's just going to memorize it, and it provides no value for them for the rest of their life. They may memorize little bits and pieces of it, but they're not gonna feel the impact, as opposed to learning how to start and make a fire. right, or like getting a piece of like bubblegum paper, aluminum, and using a AA battery and making a little fire igniter. They don't get the same type of hands-on proof of physical natural phenomena in the world, how the world works. And most times this is part of what we see. Like honestly, I would attribute to the slow bloomers or the late bloomers, where they wait till a certain point. Now, take your time on a lot of things. There's no need to rush, but they progress later on into developing what the profession or their passion wants to be, because they weren't able to see what all the passions are or been able to contribute to or have hands-on experience with. So
I want to follow up on you. I'm going to give you a different perspective.
Yeah.
So I'm going to touch on two things. So the problem with the educational system is we're still, when you talk about literature has its place because it teaches you the mechanics of how to get what's in your head out of your mouth.
That's true.
Makes sense. So
the problem with that, you're still trying to teach the way we learned to teach 3,000 years ago.
Yeah. The Romanian way and stuff like that.
Well,
or Roman way of teaching.
Back then they didn't write things down. Somebody would recite it over and over and remember it.
Right.
Rote memory. So those things, I agree with you. Literature has its place. Like Hamlet and the great classics have their place, but you should be teaching the mechanics just like we teach physical phenomena when we teach physics. You shouldn't teach, hey, say this exactly this way. Okay, and then when we talk about STEM, it's two facets of STEM. I'm going to say it's two hierarchies. There's STEM for engineers, and there's mechatronics.
Yeah.
It's two levels. So mechatronics is vocational. The problem America has right now, they do not have enough people to run the manufacturing plants that are subject matter experts in those fields. We have plenty of engineers that can design a factory, but we don't have enough artisans or technicians or
Right.
subject matter experts that can keep the factory running. That's the biggest problem I see in our country.
And I'm kind of glad that we're really touching on this because it does go into this week's topic a little bit. But the thing is, I want to kind of keep going down this road because y'all weren't here to have this conversation with me last week. I kind of spitballed it myself, thinking outside my own head. Because one thing I am pursuing with my doctorate is the fact that I want to look at how do I get robots, cobots, and 3D printers in the lowest level of education. And what I was thinking of is y'all have been in shop class. You know what a shop is. We get a shop class in school. You know what auto class is, right? Now, if you're in shop and I throw even a wooden CNC machine in there, so you can learn how to engrave CNC with a CNC and in shop, you now incorporated STEM in something that's already STEM based. However, now you're just adding a little bit more technical to it. You're adding a little bit more engineering work to it because now you're learning CAD. If you have a shop class, that shop class, now I'm incorporating a robot. Well, not a robot, but a CNC machine.
Or cobot. Maybe it's a
Well,
cobot.
exactly. But the thing is, at that same point, you incorporate RoboDrill, and you incorporate the robot fed CNC machines from like Fanuc and Haas and all of them, and teach the kids how to operate a CNC machine from starting from an end mill all the way through. So you got to make parts. Then you get into welding, hand welding, and you start getting into robot welding. You start teaching these kids what the career fields are at the start. I think it's not like we have to completely change our curriculum. I don't think that's the case. Is it part of it? Yes. Is it a large part of it? Yes. However, if we use some of the classes that we already have and we change them to meet current industry demands, even if you take that same CNC machine, you bring it to shop class, as a regular steel CNC machine, same thing, or a plasma table, or a water jet, or something like that, right? And if you sit there and you think about it, those classes really just need a shift. You got the same classes like what I took in middle school. We used to build a bridge and used to like weigh the bridge down until it broke.
So that was STEM before they called it STEM.
Right.
It was civil engineering
Exactly.
exercises, but
Yeah.
it was STEM before they gave STEM a name.
You did the underground piping flows, the water flows, and all the other fun stuff.
All this stuff came from academia.
Right.
And I was going to tell them something because I want you to follow up after I touch on. The issue is when I was in school, so when I was in junior high, so from junior high to about the 10th grade, we had what's called, all the way through high school, from the junior high to the end of high school, we had vocational centers.
Okay.
In the vocational centers, they taught welding,
Yeah.
auto, you can learn, they didn't call it AutoCAD, they called it CAD.
Yeah,
Because
yeah.
it was done by hand.
Right.
We had, you could do machining, you could do welding, you could do wood shops. I mean, they had all of these things back. They even had electronics.
Yeah.
The reason I ended up in the role I am in today in a factory is because when I was a kid, my father gave me a Radio Shack kit that had 101 experiments you could do. And I did those experiments, and I was interested in it. I started taking stuff apart and learned how to put stuff back together. That's how I ended up, and plus my father did the same type of thing.
Yeah.
He was a technical person. But the problem is when you take vocational out of the high schools, and may make people upset, but I'm sorry. You're going to get upset. Sports should not be more important than a person getting the basic skills they need to survive as a human,
I can agree with
to
that.
be a productive citizen. I'm gonna say it again. Sports should not take precedence over something that will teach a person how to be a productive citizen.
And let me, jump on that real quick. And I'm not going to get upset with it, but that's the funny part. you know, when I came into high school, we had the same vocational. We had some vocational classes, right? Then, you know, they were still like shop. You still had auto. You still had all of the major classes. You know, however, I got there right when they did away with the 4-H program where they were teaching people how to fix tractors.
That too was part of that vocational system.
But the thing is which I got lucky about is our auto teacher would still teach you how to fix the old diesel tractors. Would still teach you how to fix the old John Deeres. Would teach you how to fix your lawnmower and stuff like that, just in case you weren't getting taught it at home, right?
And I want to touch on. You know what replaced vocational? It was ROTC.
Yeah, I took ROTC also.
No, nothing wrong with it.
Yeah.
I'm just telling you.
Yeah.
That was the next vehicle to make people be able to have a career.
Yeah, like I did 4 years of ROTC in high school. I also did it in middle school too, and we still had some of the same STEM classes in middle school. But you know, I also played football and stuff like that.
Yeah.
You know, I was also on the school shooting team. Did the rifle pistol team. You know, in ROTC, doing Junior Olympics and all the other stuff. However, you know, for me, if I was to go, like, I made sure I set some of the stuff up when I did school. But I agree with you that if you are going to play a sport, you need to do some sort of STEM education course every semester while you're in school. I don't care if you take 4 years of auto. I don't care. At least you know how to fix your car. You know, I don't care if you do, like I did 1 year of cooking because I wanted to run my own restaurant. So I did,
that's
basics, and I did freaking advanced with nutrition.
So I left out home ec. So home ec was another one of those. So what I'm saying is, I'm not saying that so there are skills that you learn from being ROTC.
Right.
There are skills, when I say skills, there are human characteristics that you build by working with a team.
Right.
That's sports. There's a kind of camaraderie between the person that's next to you when you play sports. Same thing with ROTC. It's nothing wrong with either of the programs.
Oh, no.
What I'm saying is when we say we're going to cut something out, you should never cut out the thing that's going to allow 98% of the people that go into it the opportunity to go into carpentry.
Yeah.
The opportunity to do body repair. The opportunity to do welding. The opportunity to do things that today we have a shortage of.
Right.
Because we got rid of the vocational system. And it's not the kids. The kids can only use the things that are available to them.
Right.
It's the adults that decided we're going to cut out this because we want to put more emphasis on the band that's playing for the football team.
And
I could give two, because the band is not going to make you a productive citizen. I need people that can get jobs and pay taxes.
So
but I do agree with you.
First off, I want to preface and say this is 1, 2, 3 person.
Yeah.
Three people's perspective. Each person had a different life growing up. Each person had a different schooling.
Yeah.
So we do have drastically different things there. The one thing I will say is that I agree. The sports team should not be you shouldn't prioritize a new facility over a freshman building because the concessions bring more money than the students that are working. Now, that right there in and of itself is a governmental problem of the county, and that needs to be fixed. So that's a different type of situation.
Yeah.
But if we're talking about purely the training and education, I agree. Sports, it gives you the team building, it gives you the adaptability, it gives you how are you going to respond to adversity and challenge and change when someone, most of the time, that other team's probably going to be better than you. What do you do whenever you don't get what you want? Because that's what the other team's supposed to be there for. Now, the other thing is we had FFA.
Yeah.
We had home ec as well. We had ROTC. I think that the focus has shifted as a society more towards, well, I can guarantee that I have a job if I do ROTC, JORTC, then I go into whatever basic, and maybe I have some type of incentive. So that, like, some type of incentive to go and enlist, because you did ROTC for 4 years, you get to jump up, blah, 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 whatever the case. that's a system that was developed to help grow the population of the military, and it's very successful because
Yeah.
I know of 70% of the people I graduated with that said, I don't care about college. I don't care about getting a job right now. I'm gonna go straight to the military because it's a guaranteed paycheck.
Yeah.
I have a bed to stay in. They're gonna take care of me, and then I'm hopefully going to get trained in a specific category. So they took on the
Yeah.
vocational
I
part
agree.
that I'm saying.
So what I
That
would
I'm
say,
seeing.
I would say with that is,
But I'm not
Yeah.
saying that that's the right way
no,
to do
no,
it.
no, 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 no.
Yeah,
This is what. So my generation doesn't mind if people have a different perspective.
yeah.
You just got a different view from me, and I should respect your view the same way I want you to respect my view.
Yeah.
And that's how I feel. But what I would say, I was just saying ROTC, but just became a vehicle that was. We agreed that you were able to have another way to develop a career. The problem with the military is funded by taxpayers' money.
Yep.
So we're paying for that guy.
Yep.
That guy's not generating any income for
Yep.
us.
It's easy. So exactly.
With vocational, I can directly take, hey, I know I'm a chef.
Yeah.
Hey, I know how to program robots. Hey, I know how to 3D print this thing. So, and that'll get us into what we was talking
Yeah.
about, vertical
And-
integration. Maybe the guy prints the part
Yeah.
that makes a machine so another person can print a part.
Yeah. And the thing is I'm going to agree with you, and and then we'll jump into this topic that we need to bring all this stuff back. We need to make, or at least give a gateway. If you're not going to offer it in a school, give somebody a co-op where they can go do it at a local tech school. But here's the thing. Here's where I have heartburn. Not about the topic, but about how it's administered.
Yeah. I think I agree with you on this part.
He already knows where I'm going with this. Because we've had this conversation probably 30 or 40 different times. Even before we had this podcast, we had the same exact conversation. The industry needs to step up
Yeah.
and stop being, I'll be very blunt about it, shitbags, when it comes down to supporting their next generation of worker. For example, future FFA. If you're going to have an FFA, by God, that needs to be supported by John Deere, Caterpillar, and all the big name people. They need to jump in there and say, hey, guess what? We're going to support this. If you're going to have a program teaching people how to fix machinery and stuff like that, those guys need to step in and say, hey, guess what? We're going to step back. We're going to support this 110%. If you're going to have a welding program, guess what? You need to have the support of some of the big name welding companies that said, hey, guess what? We're going to support this.
Yeah.
We're going to get these guys through this. We want to show them why we love this industry.
And we're going to donate equipment.
We're going to donate equipment. Same thing with robot manufacturers. If you can't donate equipment, show somebody how to 3D print that robot.
Yeah.
And same thing with a CNC machine. If you cannot donate equipment or you can't do that, help them find older equipment and teach the teacher and teach the students how to repair it.
Because you know what that does? That gives you a workforce that's able to maintain a manufacturing plant.
Exactly.
So this will be my last point on it because I don't want to harp
Yeah,
too much
well,
on
we
it.
did kind of
because
put our
Yeah, I
it
let
is
that one
what
squirrel a little bit.
It is what it is. At the end of the day,
Whatever.
it's the phrase you can lead a horse to water, but you can't make it drink.
Right.
Throw as much money as you want at this.
Mm-hmm.
If you don't make it interesting for the kids,
Right.
nobody's gonna stay for 5 minutes. So what I'm saying is when I went to school, the people I graduated with, I'm one of very few that said, I'm gonna go pick this path of study. I'm gonna study up on this, and I'm gonna try to get a career around this. Every single other person said military because it was simpler.
Mm-hmm.
It's because the system was set up in such a way that you're going to be immediately compensated. Also, by the way, if I want to go get that schooling that you yourself is going to go have to work to pay for or ask for a federal loan for, I'm going to have a VA loan that's going to pay for mine later. So a lot of these people, that's why I'm saying that everything else fell by the wayside. Like, they took money from the band first. They took our art program. They took away home ec, but they kept the sports teams, and they kept some of the
They don't-
vocational like that
They only
side.
did the sports team because they was getting paid.
They were getting paid, and that was
They
it
only
was
did the
giving them a
ROTC
kickback
because they was getting money from that.
because they're
too.
going to competitions and they're getting kickbacks.
But what I'm gonna tell you is, when I was in school, I know this a fact, 100%.
Mm-hmm.
An electrician does not have to go to school. An electrician gets an apprenticeship.
Yep.
A steel worker does not have to go to school. He goes and gets an apprenticeship.
So that's
I'm saying the trades.
yes.
The trades, I can, if I had that in place, where I can give you a trade and certify you before you get out of college, excuse me, out of high school, that you are a good welder, good electrician, good plumber, and blah, blah, blah. Then we don't have to have people that, you know, well, we don't have anybody do this. We got to let people from other countries come in here to do that.
Right.
No, we don't. It's people here that can do that.
Yep.
You just not putting that in the school systems.
And if the
And those
organization,
things you're talking about have their place. And I'm 100%
Well, I'm not debating
agreeing.
one for the other. I'm just saying
No,
that
but you're right.
they're
Without
all
those,
there. And how do you build the passion in the kid to want to do that, not just throw everything and make it available and then throw money at it?
I
You know, I
think
did because the guy uncle was an electrician. The guy uncle was a plumber. The dad was an electrician.
Yeah.
So what you're talking about, 100%, without those things, it would even be worse. The military has always been a place that you can elevate yourself. Football has always been a vehicle for people that didn't have the tools to elevate themselves. But what it does for the economy is it takes from the economy. We need people to work in these factories so that we can make products and not be a service country and be a product country.
I don't disagree with you.
That's-
I'm
that's
just
what I mean.
saying
That's all-
that
that's
the
my
way
only-
that it's
and-
set up now is to
Yeah.
incentivize to go to the military. You do your
Yeah.
4 years, you get out, and like so. I'm not okay. I don't want to say that
No, you're right. I don't think you're saying anything wrong.
going
I
into
think we're-
service is wrong. I don't.
We're
No, 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 no,
agreeing.
you-
I think
yeah.
we're agreeing. I'm just saying
everybody,
there's just different ways to do it.
everybody's
It's simpler to
agreeing.
explain that to them.
Yeah.
To this is how you go get what you want. You go do this. You go do that.
Right.
Instead of just going to a
And
4-year
Here's
career.
how to fix it, and then we can move on.
Yeah.
And you finish up. I'm gonna say this.
Yeah, okay.
The way to fix it is the military should do. They should partner with companies
Yeah.
that need these skill sets and bring in a person to teach guys that's interested in going into these manufacturing positions before they get out of the military.
Here's the good thing about that.
Yeah.
The DoD does have something called the transitional programs, where they actually do partner with big co-organizations, stuff like that, to bring these guys in when they transition out, right? A lot of organizations are part of that. ABB's part of them. Caterpillar's part of them. All your big name companies are part of these guys. However, and that is something that the DoD has been doing for transitions, because we know that the transitioning out of the military sucks. It's not fun. It's a lot of effort, a lot of work, and sometimes you're bound to fail, and that's kind of what happens.
That's okay.
But the thing is, and not only the fault of the veteran, but kind of some faults of the companies. However, but not of the ones that are supporting the transition periods. The guys who are they're giving them jobs and stuff like that, so they're giving them that.
But manufacturing is a different,
Right.
totally different from being in the
Right.
military.
But the thing is I agree with you that they need to make it interesting. And I think that if organizations and companies would partner with local high schools that they're in
I
their
really think
area
that's the key.
to make it a little bit more interesting. For example, you being from North Carolina, you get some of these guys who are now partnered for like auto shop and welding and stuff like that. You can partner with some of the race shops out of Mooresville. Teach the kids this is how you work on a race car. You can weld on Monday, race on Sunday. And the thing is, get them interested in building cars, doing aerodynamics and stuff like that. Still a blue collar job. You're building friggin' race cars. You're building high performance engines. You're doing all this stuff. The thing is, I think if it is local business partnering with these schools,
Yes. It should
you
be.
know, to really get that interest
100%.
out there, I think is what is needed. And the thing is, like for example, down in Florida, we have a lot of boat manufacturers. You get people in there, you teach people how to, and you have MMI and stuff like
space.
that,
There's a
right?
lot of space.
Organizations, which you get a lot of that out of the schools in Titusville. Titusville's got a lot of partnerships with NASA, Lockheed Martin, and all of them. But you also have some areas where, like some of the high schools in Florida, actually will teach you how to fix marine engines. because they're partnered with Boston and Whaler.
And that's
And stuff
what
like that.
It used to be that way. Is what I'm saying.
Yeah.
Like,
And the-
like we talking about interest. I'm telling you, like, there was no need to tell a person, "Ooh, you welding? Can you show me how to do that?" The problem is it's not in the schools. That's why you don't have the interest. For mechatronics, not STEM. We're talking to animals.
Yeah. Megatronics is a
STEM
different animal.
It's architect. Mechatronics is maintainers.
Yep.
It's two different.
And that's
classes.
why I push for robots in schools. But the thing is this entire conversation we just had.
It was actually pretty good.
It's something we enjoy talking about, and something we really do enjoy.
Yeah. Just saying, living it and go like my entire friend group. Not a single one went to college without.
Yeah, most of my friends are military; they're chefs.
Because they, well,
Or generally work for Disney.
The problem being is that from them, and it's just a small group, of course. But the problem being they don't see the path, the easy way to get to where they need to be, where they want to be,
Yeah.
through going to college or
Right.
or going to go to a trade school. They don't see the payoff at the end of the road. Even though now they did the time in the military, and they're like, oh man, I could have did 4 years in college and been at this pay rate well before.
Yeah.
So I'm a big supporter of the military. My father was in the military.
Yeah,
so
yeah.
So for me,
They take care of
there's
you. They
nothing
really
wrong with the military. But what I'm telling you is, if you go into automation and controls right now, you can make anywhere from 160,000 a year to 200,000. If you work for yourself, it's way north of that. What more motivation I got to give you?
Right.
There you go.
And
Yeah, I
the
mean,
thing
that's
is that kind of leads us into this week where Ed kind of touched on it, is vertical integration. It's starting at the bottom and working our way up. If anybody's not familiar with vertical integration if I build a MES system, I build a robot on top of it. Then I build a CNC machine on top of it. Then I build all this on top of it. So I vertical integrate on top of that one platform. Or, for example, if at one point I've heard it nicknamed vertical upgrading. So, like we talked at lunch, you start with an Ender, you move your way to a Prusa. You go from a Prusa to other types of machines as you work your way up. Then you side load that process and you build on top of it MES systems, slicers, and all this other stuff. Vertical integrating can also be vertical upgrading, depending on how you look at it. Depends on where you want to start and where you want to go. It's like making a robot and robot arms. Stuff that the attachments. Same thing.
So, like, another way to look at it is ABB builds the components. ABB sell the components to customers,
Right.
As warranty parts or replacement parts. ABB builds the robot with the components, and then the robot can now be moved to processes that use the robot to make components. So that's when I think of vertical integration is from the seed to the blossom, from seed to blossom. So that's how I look at it. And like you said, the verticals also would have horizontal integrations that you would use for tools that you need for dealing with each of those stages. Now, where it gets interesting is when you can take, instead of being strictly vertical, where you can silo some processes and say, hey, I keep harping on the unified namespace, which is kind of like a silo. These systems, instead of having to go one level up to the next level up, you go to one center of trust. Each one can pull from that information up the verticals, across the horizontal things that work inside of those verticals. And then now you're optimizing the MES, the SCADA, the plant system, the sensors and actuators below that, and even further when you go into AIs, where we're talking about making business decisions for the company that spans more than a few days. It spans a few years.
The OT triangle.
Yeah. So when you talk to me about vertical integration, it's something that made sense to me. I mean, I've always, I mean, coming from what we do in school, what I've done in school is you break down the systems. Everything is a sum of its parts, right? So if I'm able to break these things down and make these connector pieces, this is where APIs get so much more important, especially in the software world. Is like if I can make a way for my applications to communicate with each other, or send this data so that I can display it in such a way that I can read it, then it's gonna make whatever that data is showing more impactful and easier to see to customer, business, whatever the case is. So vertical integration for me is how do I use what I currently have, or how do I like you said, upgrade? How do I use it to facilitate or to make it more efficient? For me, a lot of stuff, I mean, IT side, it's hard for me not to think about data being like the driver of a lot of it. But like if I had to say build an application in with the already working system, that's something that I would say is vertical application, because you started at a point, which, by the way, time passes, you can't go backwards in time. You start at a certain point where you have maybe version 1 of your system, and then as you're at maybe version 20 and you're like, hey, I need to add this new feature here, you need to integrate that. Maybe it's an application you need to add that handles the MQTT data that you didn't have when you first made it. That's totally possible. So you need, how do I connect this into my system? How do I get it to communicate? How do I get it to become a part of my daily operating procedure?
So
I'm still looking for that TARDIS so I can go back in time and freaking start fixing things that were broken a long time ago.
So you actually can travel back in time.
Yeah.
I just can't. So
You need to go
we're not
faster
talking
than
time
speed of light.
travel.
Well, you need to go at 8
But
miles an
what I
hour
said,
and you
I
can start
can-
piloting?
I can travel back in time.
Yeah.
Because with data that's been clean, normalized,
You see what happens.
and analytics that's been applied across it, I can take that data and predict ahead.
Right.
That's what I mean by the going up the verticals and siloing the protocols. MQTT should not worry about profiting it. It should worry about the data it wants to get from that process.
Right.
And that's what I mean by siloing.
Yeah.
I think you're in the same brainwave. Go figure. Very much you'd understand that's the case. I was thinking about this on the way home. The king of vertical integration is Industry 4.0.
Yeah.
Industry 4.0 is the king of vertical integration because you can build whatever you want on top of it. And now your data flows north and south because now you have a data lake, more or less like a data puddle when you first start out. Then it turns to a lake, then an ocean, and then God knows what the hell you know with. But you pull that data through your system and integrate that way. For example, if you're new to building MES systems, right? And you're new to building robotic systems, and you're new to integrating robots, and new to integrating CNC machines, flow jets, whatever. You need to start with that Industry 4.0 connection. You need to start with the data lake. You need to start, even before you turn anything else on, that should be the first thing you turn on, and then tie everything to it. So it collects all of your data as you install these systems. Now you have not only your startup data, that is now data you'll never get back. You'll have,
So that's your historian.
right, you'll have your any of your test data that you've been playing with. You'll have all of your how you commissioned that particular subset of hardware. And the thing is then once you build your MES system on top of that, it sucks in all of that data from that IoT system and becomes a sponge.
But only.
But only what you subscribe to, depending on
There you go. That's the key.
depending on how you write it.
We're not polling. What if I got a silo? I'm not polling every so many milliseconds,
And-
like the old system.
Right. The thing
that
is
went up the vertical.
As you can use, MQ admin, you can use, polls and stuff like that, queries. But the thing is, it's there if you need it. It's there if, hey, guess what? I need to have part of my MES system. I need to see my robot data. So now I'm going to pull all of my RB data out of my Industry 4.0 and display it on my board. Even though as I add robots on top, I'm connecting a robot and sending data to the IoT back up into
Right.
the MQT, the MES system, and you're slowly but surely building that circle. But you're the head of that unified growth and stuff like that, and the vertical integration side of a system is Industry 4.0.
Yeah.
It's all your sensors, because the thing is, you're going to vertically integrate sensors
Well,
all the way up the chain.
Even with that, the problem is I can remember when we were using DDE and OPC and these type of things to do data.
Hey, OBC is still around.
It is, but it's two different type of protocols.
It is.
And the
It
problem is when you go up the vertical with different protocols, you got to have a way to transform that into something that each. So you
Yeah,
one,
OPC is pretty terrible.
it's inefficient. It's for
what
what it is.
For what it is, yeah.
If you got OPC, it's nothing wrong with OPC UA.
Right.
I'm saying it's the method you use to collect the data.
Yeah.
We don't need every event. I don't need when the robot wake up. I need to know this specific thing. I'm saying like maybe
Light bulbs on.
well maybe
Shit.
on the weekend the robot goes into a hibernate mode.
Yeah.
I don't care. That's your
Not-
SCADA system.
not for my- yeah.
The
Yeah.
SCADA system handles that.
Not for my like preventative maintenance. Not
But
for my
if
like
I'm
process
a guy
management.
that's looking at data that's going to transform my company, that's going to make me look ahead,
Yeah.
I need data that's event driven and only the stuff I'm subscribed to.
Yeah.
The spam I don't care about. The spam can stay at that level. Put a historian for that. If that's what you want, make a historian. Make an event that triggers the historian to send data to your silo. I'm telling you, that's the game changer.
Yeah. OPC and the OPC UA environment is great. Don't get me wrong. There's a lot of stuff built into it. However, you can't vertically integrate on an OPC system. You can side load it. OPC is a good side load system. It's not a good vertical system, because the reason why is OPC in its setting. They changed it throughout the years, but in its setting is literally the fire hose of data.
What do you mean?
It is, oh, the door opened.
No, you just
Oh, look, somebody plugged this thing in. It's going to
on
tell
off.
you
It's pulling
yeah,
every
exactly
message that's in your system.
anything that you never want to know about. You're now finding out. Oh, there's a slight
no
vibration.
filtering,
No
yeah.
one cares.
And some of that is because people don't implement a good alarm philosophy.
Right.
The alarm philosophy should be nice to know,
Mm-hmm.
need to know. It should be two categories. Nice to know, need to know.
Right.
Nice to know, hey, somebody opened the door. That was nice to know. Did it trigger an event? I care less. I need to know, hey, that robot lost his heartbeat.
Yeah.
And I lost safeties. To me, it's nice to know and need to know.
And now, if you want to talk about something that you can vertically integrate on OPC UA, not thinking about it, is Ignition.
Yeah.
Ignition is one of the very few systems that you can vertically integrate upon an older, even a newer OPC UA system, because it absorbs it. It takes all of this data in and turns into a data lake and plays with it. But, and the thing is that you don't have to be a rocket scientist to use that type of stuff. At least and the thing is they offer free training. So now your vertical integration becomes easier because it's free. The stuff from them is they have an entire academy, the Ignition Academy, built out so you can learn Ignition, you can learn how to program it, and you can learn how to vertically integrate on top of it.
And they do offer those tools for free.
Exactly.
It's
a certification course.
The software is accessible.
Yep.
It has a time frame on it, but it starts over after a certain amount of time. But what I'm
You can be a certified integrator for free,
Yeah.
and then learn how to vertically integrate OPC UA and
back to what we've been harping on. But
Right.
What I'm interested in is what do we think the advantage of or the potential rewards for using vertical integration?
Oh.
So what benefits do we get from vertical integration?
I mean, we're constantly talking about I mean, if you're in a production environment, you're constantly worrying about uptime. So vertical integration, like Ignition's a good example. You're vertically integrating a system so that you can validate quality data in the moment, in real time, and see. I mean, most places, like if you're in any type of like automotive, aeronautical, marine sales, like if you're selling something that's costing a lot of money and you're trying to have a certain type of quality, like you need to have checks in place, and as your product gets more complex, you need to have more tests and checks. Ignition's a great tool for this because they use existent technology to be able to tell you what the behavior of your processes are, and in a lot of cases, companies use them as, quality final inspection. Like, hey, this is going to save my data. This is going to make sure I get my results. So hugely important on the side of vertical integration, because in a lot of cases the company started without having some of these features, and as time progressed, these features have become necessary and vital. So yeah.
I see it as a cost savings, to be honest with you.
Yeah.
It's going to cost you more to go vertical. Yes. However, in the long run, vertical integration is going to save you money, because now you're producing interior your own operation, you're maintaining your own operation, you're driving your own operation, and especially if you're a service oriented business, now you're taking whatever you produce, you're selling it, maintaining it, integrating it. So now you're vertically integrated on top of your product that you've built.
Yeah.
So now you're dealing with product, subject matter experts, product experts, and people who, trained and been ingrained in this type of stuff. And, the thing is you kind of see that when you start talking about, which is kind of funny, I'm going to say this, is you're vertically, like, for example, the Voron community. The Voron community has not figured out how to vertically integrate an open source product.
So, so this is
If you think about it.
Yeah. So I like this because I want to give you the second question. I have one more question after this, and then you can finish your thoughts, and then y'all build on the second question. So, how can vertical integration make an impact in additive manufacturing?
Ooh.
Well, I mean, I think it's already something that we see.
On scale, at scale.
At scale. Okay,
At scale.
That's fair. Because I was gonna say, Caracol does it.
Yeah, exactly.
Caracol vertically integrated the change of their tool ends into a KUKA robot. They started with the KUKA robot, and then you can grow from there. Orbital use another company, same thing. They started with the KUKA. So these are a couple examples I think of on a scalable, either already at a large scale. The robot's a lot bigger than people realize. Or a scalable situation by getting multiple units and being able to vertically integrate multiple tool ends. For additive manufacturing, I mean, this is something that I think is a big question, and I'm probably gonna go and learn a lot more about as far as the metal side, because in some of the papers that I've read recently in the past few weeks, they're utilizing machine learning technologies and methodologies to incorporate into the a powder bed fusion or arc welding, SLS, or selective layer sintering machines. So what they're doing is they're thinking about, how do I detect, like we talked about spaghetti detector for a long time with Creality. So they're talking, like this most recent paper even said, how do we recognize in real time with machine learning techniques localized heat accumulation or buildup. So what it explained is that we set the print in such a way, because it's metal, as it's printing, it has strain and wear and holds temperature, and inherently we've talked about it with relativity space
and some degradation.
Yes,
The
exactly.
material.
Because it's reheating, it's coming in contact with the next layer, is heating the layer below it. There's always heat dissipation. So what they did is they cut a whole bunch of squares and they put it on the paper, and they had a certain layer height, and as it was printing, they have an infrared thermography camera I might have that wrong. An IR camera, and they're looking at the heat buildup as it's printing. And what they noticed is that on some of the edges, you can see heat stays longer than it needs to. There's no heat sinks. So it became, how do I vertically, how can I integrate this system of detecting my heat? This is just an experiment that they did, just of detecting it in real time. How do I now integrate that into my current processes so that I can try to avoid the negative outcomes of the heat accumulate or the heat buildup, which was in the metal product or whatever they were using. I think it was an aluminum like mixture. The edges of the square or the cube that they built started to bubble. Like you wouldn't even think of a metal as bubbling, right? But on that layer, unless it's really
unless you use melted metal, and it does reach a point where it becomes liquefied.
exactly.
So here's the thing I want to throw in there, and it's not for this week. It's just it's just a thought. Steel and aluminum, different melting ranges, right?
100%.
What if whoever got the brain out there can figure out how to make these layers where there is a different temperature where you don't get where it doesn't deform or you don't get degradation.
Delaminate.
I don't know how you do that.
Yeah.
Maybe you have to do something on a nano level, but I'm saying my solution would be not the heat sink because the heat sink draws heat. We need something that says you can heat. I can take a piece of aluminum and a piece of steel. Aluminum will melt before the steel.
So yeah, that was actually the next point that I was going to get
Okay,
to.
I'm sorry.
So no, it's a good idea. It's a natural thought progression. So we're like, okay, well, if I have heat buildup, how do I get around this? How do I? First off, machine learning was one way that they were like, okay, you can actively detect it, and then you can adjust your parameters. But the problem I'm seeing with this is a lot of process improvement that you're seeing. That you're like, okay, well, if I just do the process better, it works. I agree, and I raise you the piece. What if I made my supports in a material that would draw the heat and also has a different melting point, so that would help me in the situation of where I need this part to be have such a form, and this support isn't necessarily there to hold the part up, but to draw the heat away.
So I'll raise you again. I say ceramics and heat shield.
Call.
No, seriously. But it is mixtures, and then they've started building composites where it's mixtures of the it's become an alloy.
When we bring an object back into our atmosphere. How do we control the heat?
You have the
on a vessel that's coming from outer space back into space. They put heat shields.
Heat shields, heat deflectors, yeah.
So
a
a
bracing
combination
material.
of what you're saying,
Exactly.
built into diverting heat.
Yeah.
Heat shields to keep this layer separated from that layer. This layer cannot get hotter than this layer because this material. But it has to be on a nano composite level.
Well,
It does.
That's
Now
when you start getting into like ablative heating and stuff like that.
But and then of course the differences come from powder bed fusion being the whole layer gets.
And that's what I'm thinking. I'm
The
thinking
whole
not.
layer
I'm
does
not talking about printing this way.
You're not
I'm
talking.
saying
Yeah.
you have some way with powder
Yeah.
or whatever you want to use, or some way to make a solid, and
yeah.
then you put it in a solution, and it.
See, and I'm just saying that there's two.
However you
differences.
wanna do it.
Well, doing the layer by layer, that's one thing because it hits the entire area with a temperature, which inevitably, if you have a greater cross section, it's gonna hold more heat because it's just larger surface area. If you do, it's called direct energy deposition or selective layer sintering. If they're doing it like that. Or selective laser sintering. I might be wrong on that.
But I know we know what you're talking about.
But it's a single point laser that's making and building it. And in that case, it's a little bit easier for me to control and make sure that I don't have defects due to my heat. But when I'm doing that whole layer, it's more susceptible. So these are considerations, right? Like things you have to think about.
So I'm gonna give you the third question, and you need to touch on the second question and jump into the third question.
God damn.
So the third question is, so we said, how does vertical integration impact additive manufacturing as it stands? How does vertical integration impact Industry 4.0 or the factory of the future or smart manufacturing?
I hate you.
up the verticals.
Well, I get it. Yay.
Go ahead.
We're going to be here a while. Sorry, folks. We know you all eventually want to get some
I
rest.
said it's not real.
Damn. You know, I don't know if you ever watched WTV back in the day, but damn. You know, you start getting to the point. Like, I'll jump back to question 2 real quick before I can jump to question 3. You know, I would say we're building a base here, but I'm kind of building gravel. But for me, when you start talking about vertical integration, especially in the additive manufacturing world, you really start getting into, you got to start from the open source world. You know, we vertically integrated everything coming from open source. We've started, if you think about it, the open source community is probably one of your largest manufacturing entities that's not getting paid.
And the best scrutiny you can do for any product that you put out there to a
Right.
community that's using your product.
Yeah.
And the thing is if you think about it, also, they're making products better than most people. I guarantee you there's some people that would rather fly in a spaceship that's designed by the open source community than the people designed by anybody else. Why? Because at least they know what they're talking about. But the thing is you have like the Voron community, for example. They started with a small little printer, open source idea of RepRap, and took this thing and blew it up all the way to the point where now they're coming out with a Voron CNC machine that's 100% that's open source. That's build it yourself. They live and die by this idea. I've built one. I know. But the thing is they vertically integrate on it because now, not only, for example, I built a 2.4. First thing I did is, I don't like the hot end. Let me swap the hot end out for a more expensive version. You know, let me go do this. Let me do this. Let me add this to it. Let me add this to it. Let me add this to it. So I'm slowly but surely vertically integrating with all these other organizations and products and stuff like that from closed source systems.
And you're also showing that all these products are
They're working together,
compatible
right?
with this platform.
And so then you start getting into the fact that you can tie that in Industry 4.0 if you really wanted to. Because the Clipper interfaces coming from additive manufacturing can actually point to an MQTT interface and feed everything else. Which it can actually pinpoint the nozzle location every time it moves. So if you really want to overdo data, just don't give it just give it a freebie, right? So I also want to touch on a company like you talked about, Caracol, and all of them. I want to talk about a company called Vertico, out of the Netherlands. It's a robot 3D printing and additive manufacturing company that doesn't use plastic, right? They use concrete.
Yep.
They're 3D printing with a robot arm, with an ABB robot arm, because that's what they have, with concrete. You have the EDU cells, the small cells, the large volume cells, the 7-axis cells, and stuff like that on sliders. It's insane. But the thing is they're building on top of that entire automation controls mentality, adding concrete to it. So now you've moved into industrial construction and art.
But no, yes, they do that. But it's a company here that we talked about before on this podcast that's been making affordable homes.
Right.
And I'm assuming that at some point they're going to also get into that.
Yeah.
That same area.
They're actually the guys who are making the concrete homes are actually the same guys who are flying one of their robots, one of their printing machines to the surface of the moon to be able to build like areas of habitable areas using regolith and lasers. And I don't think they're attaching them to sharks, but they're doing something. But if you know what movie that's from, thank you. Good old Austin Powers.
It's a good movie.
It is.
No Sharknado?
No, Austin Powers.
Yeah, I got it, but no Sharknado reference.
No,
No Sharknado reference. Sharks.
it's not
But
Shark Week.
lasers.
You only get one.
But the thing is they're vertically integrating. Now they're literally vertically integrating because you can't go very much higher. Until of course somebody figures out how to send a 3D printer to Mars, which kind of haven't got that one yet.
But
Could
I
be
mean,
that soon.
Coming.
we sent a
Eventually.
rover. We sent a rover.
We could send
Well,
it.
technically, the rover did 3D print something.
Yeah. But I mean, if we can send that technology,
Yeah.
it's feasible. That
We
you
we
can
put a
send
helicopter on Mars.
Yeah,
So I'm pretty sure a 3D printer is going eventually.
Here's the thought. Mars is entirely populated by robots. So just so y'all know.
But
Technically.
here's the thing. I'm adding a footnote, so I'm adding the wrench. Here comes the wrench. So, with all this vertical integration we're talking about, and then we're talking about space exploration,
Yeah.
is it possible to use some of these techniques with vertical integration into space?
Yeah. And the thing is, let me bump to 3 real quick before I answer
Okay, my bad.
3.1.2.4.6. I swear, you got a future as a professor. But the thing is I think when we're looking at 3, when we're looking at the question 3 that you had, the Industry 4.0 and the vertical integration of Industry 4.0, smart factories, smart manufacturing, and advanced production facilities. I think that now you're going to see systems like what Siemens has, what ABB has, what Fanuc has. All of these AI, VR-based manufacturing design sets that tells you exactly how to build your system, what type of data you're going to need, how to build the building. So you're going to digitally build that building, do a walkthrough digitally, communicate with all of your equipment before you pour the first footer. Yeah. And when you pour that first footer, there needs to be a system in place to monitor whatever is going on. Because the thing is once we pour the first footers, once we run the first electrical lines, we have sensors that's monitoring our electrical consumption. We're monitoring what our heat pumps are doing. We're monitoring how much fuel we're using. We're monitoring what our output of electricity is. So technically, I've already vertically integrated from the point of using VR to build the system, using Industry 4.0 to collect the data from the energy subsets that I'm using. So now I can refine my building design in process to make my building more energy efficient, to make it easier to use, better for the environment, even before I put my equipment in there. So now I've put my equipment in the buildings, and they have the best chance to do what they do best because they're in the best atmosphere. Because now I take all that data and I combine it all. And I take all the data from the robots, paint booths and stuff like that. And I vertically integrate on top of that data to build a system on top of it to control everything below it. Now I have every single piece of data you can. Industry 4.0, and the smart manufacturing subsets, and are going to be the wave of the future. It's going to be how we vertically integrate going into, I could see it maybe say 2030, maybe, and we'll start seeing more VR designed, VR prep, production lines. Yeah. As those things become more wanted.
So no augmented reality.
Right. So as we see the stuff like what Fanuc's working on and ABB's working on, going to the fact that I can throw on a set of VR goggles, I can set up my robot and simulation software and see it in space and see what it's going to do. So I think as we get further along, we'll start being able to design buildings with all of that data and all that stuff in there to see exactly how my lines interact, so I can kind of see where my crutch points are and stuff like that. So I think that we're going to be building systems in VR before we actually build systems on the ground. And the thing is what that does, that gives systems designers and systems architects a head start. Because now I know exactly what kind of data I'm going to be using and receiving. Now I can build my system before I build my hard pack. Now, jumping into your, fourth question. Vertical integration and
So let me clarify a little bit.
Okay.
Because I want Champ. We getting a little long-winded, so we're gonna try to wrap it up.
Yeah, just a minute.
So,
Say we already probably.
well, I just,
Right,
I wanna
we're
give
actually
it-
not too far
I just
from
want
that.
to give
We
a
spent too
little
long at the
clarification
beginning.
to that question. When we're speaking about space exploration
Yeah.
and using some of the things we talked about tonight with vertical integration.
Yep. So think about this. Okay. Sierra Space, Blue Origin, and a couple other companies, God, let's hope not Boeing, are getting together to build Orbital Reef. They're building and they're going to be testing the new Orbital Reef modules on the International Space Station before the International Space Station does the Great Plunge. So what Orbital Reef is? Orbital Reef is the first ever commercially designed, flown, installed, and maintained space station
Yeah.
ever to exist. And, it's going to be fed by Sierra Space. You're sending up their aircrafts and filling up, and with everything.
Is it Sierra Space?
Sierra Space is,
Based out of North Carolina.
yep, the Dream Chaser
Yeah.
is going to be it's supposed to be one of the aircraft that's going to be going up and dropping off equipment, stuff like that. Eventually, that same exact space plane will be ready for human flight. So we'll have and the thing is, it's going to land just like a regular airplane, just like the space shuttle did. They're actually getting ready to launch one here soon for a test. But then they're going to be working with Blue Origin. Blue Origin's going to be handling a lot of the heavy lift to get that equipment into space and into its organization, into its parking space. And then I think Boeing is going to be flying or attempting to fly astronauts to into the space station. Getting them home is a different story. Getting them there, we can do.
We'll get you there. Yeah.
Yeah, we'll get you there. It's kind of like Spirit Airlines. We can get you there. Getting you home, different story.
Might not have the wing or the tail when you get there. It'll get there.
We'll arrive on site. What is it, like Enterprise? We'll pick you up. No, they won't.
We'll leave you there.
But all fair and well that the two astronauts, Butch and Sonny, they are on the International Space Station. They're doing well. Everything we've seen, the Starliner did come back in one piece.
Yeah.
It made it back. Actually, very well, surprisingly.
Yeah, it's not like they're not getting taken care of. They're getting taken care of.
So the thing is we wish them the best of luck as they have an extended vacation.
I bet you they're not. I bet you they're doing work.
Oh yeah, I know they are.
It's not a vacation. You gotta.
They're hoofing it, floating around. But the thing is if you think about it, as we build infrastructure in orbit, we build manufacturing facilities in orbit. We start, and when that happens, you start vertically integrating to the fact that now we're flying tourists to orbit. One of the major jokes is eventually they're going to have a space hotel that is going to remind us of Lost in Space, the new episode, the new season from Lost in Space, the circular hotel, something like that. However, they don't think that's ever going to work. It's like when they're talking about the space elevator.
That seemed like a bad idea.
Yeah, that just sounds like an oops moment.
The Coriolis effect. That's all I have to say.
My thing is cable snaps, and now you become the fastest freaking, roto drill on the planet. Yeah. You are digging for oil, literally. But
It wouldn't have worked.
right, but for me, we're going to see that when we start getting the new space station up there. Start seeing a lot of commercial activity on orbit. We already are, and I think we're going to start seeing more, especially with what they're flying 3D printers to print human tissue to the International Space Station in the next couple weeks.
Yeah. I wanna harp on this too. And then this will be probably the last thing because this is something that I also talked about in one of my discussion boards for one of my classes. Is they were talking about what other types of someone had a question about if you were able to print in like 100% tungsten or 100% like titanium, these metals that if they're pure, they melt in the like 3,000 degrees Celsius range, which is wild.
Yeah.
Like we would be vaporized. So you think about that question in and of itself got me thinking, and we also have already looked this up. NASA developed about 2 years ago. It's like GRX 1080 or something like that, and so this material is a combination of like cobalt, aluminum, and like zirconium, I think it is, or something along those lines, or chromium or something like that. But the combination is such that it can withstand of up to 2,000 degrees Celsius. Not quite to the perfect, like the pure of tungsten and titanium and things like that. But still, this is the powder that they developed to print on a powder bed fusion printer that they're using in space. So that's where the idea that you're saying, that I think like it's only a matter of time. It's not a matter of if we can, it's when we will.
Right.
The space station will be built, and it will begin building modules of itself. Of course, once it becomes cheap enough to build on site, it will build its own modules. Or I can only think of a situation which we get into like a ship of thesis situation of it just prints another one of itself, and then it's like,
weird.
okay, number 2, or is it number 1 because it was the first one and it was repairs. That's a different philosophical question. But at the end of the day, NASA is already developing. The material scientists are already working on how to get these materials, how to work with the regolith, which is the moon dust, and how to develop and build off of these things. So bringing it into additive just makes sense. Additive is so much better than subtractive. I don't need 2 tons of this. I just need as much as I need to make it, right? Instead of using the 2-ton block. So in those situations, developing a powder that can withstand the extreme conditions of space and heat of space, and then making that into a situation, and putting it in a situation where it's building and developing modules or on other planets, helping terraform, that to me, like, it's almost gone way past the vertical integration we were talking about in the beginning. By that point, I would expect you to have to be able to have like MQTT or some type of smart sensor or some type of data acquisition that gets you quality points about this system, and that's gonna have to be, if you're not on site or you're not on the moon, you're not in the space station, that's got to be damn good signal and great like recording software or whatever the case is to get you everything you need on Earth and make sure it's in the right time, because data is not instantaneous. Like as the spaceship gets a little bit further out in orbit, it may take a little bit longer for communication. The moon may cause some issues with interference. But like, yeah, if we're orbiting, even like let's say the spaceship's orbiting the moon, there would be certain points where it's on the other side of the moon. The entire body right there is blocking the signal. So there's going to have to be thoughts, consideration into if I lose connection, how do I keep the data, and then how do I get the data there anyways. But those, like, to me, that just comes hand in hand with questions of integrating vertically in a system like that with AM, of course.
And the good thing about MQTT and stuff like that is most of your messages will stay stagnant until they're fired.
Yeah.
So, which is kind of good, especially when you're dealing with, like, what you're talking about, the dark side of the moon. You start dealing with RF issues, a lot of them, because we don't have repeaters on the moon to be able to bounce the RF signals off of.
Why can't we
have
have like 2
mirrors.
satellites on the side right
That's
here?
what they're building.
Yeah, exactly.
They're building the outpost.
Well, the thing is it's not an issue if you're talking point of sight. So you're talking point of sight communication. Point of sight communication has to line up.
Right.
So the issue is, if we're using point of sight, then yeah, that's a problem. However, if I have satellites that are already in orbit, you put a satellite in orbit that communicates with microwave, which is a different.
Yeah.
So
Different
let's do it this way. We use wireless, right?
Yeah.
And we use what's called mesh networks, right?
And the thing is that's
set
why
up a mesh network in space.
There you go.
that's why they're
There you go.
building the Deep Space Network, which will have the OTH over the horizon, communications on board and stuff like that. Now, you heard John bring up regolith. When I brought it up too, everybody's brought up regolith at least one point. You need to understand what regolith is. Regolith literally is just like planetary talcum powder. It is as fine as chalk. When you see it, like they have it at Kennedy Space Center, they have it at all these locations where they also have the substrate that they test with, that they used, regular moon dust to come up with. It is literal talcum powder. It is the white powder that you get from chalk that you're using. So, keep that in mind, especially when you start thinking about, laser sintering and stuff like that. It's different powder levels. So you will use, so to be able to build a layer on layer on layer with talcum powder like that, it's one hell of an intervention.
Well, yeah, I mean it's impressive.
So the thing is it's gonna get fun. You're gonna see a lot of vertical integration happen. The next probably 3 to 6 years.
Mm-hmm.
So I think when you're talking fine particles, compression is normally the thing that you use. How you use a laser similar to do with compression, the phenomenon of compression, which is normally you're taking something and pushing it. I mean, I don't know how you do that, but that's probably the way you make something stronger. Yeah. But to get off that and to finish up, I will say this: additive and subtractive will have to work together because the tolerance of additive is still not where subtractive is used to make things within certain microns. We're still not there, even with metal. There are still some processes that have to be done to that material. You can't 3D print a gear right now that has to be a certain precision and put it in a watch. It's just not there. It can get there, but as of today, they are not able to get the same precision that you can get with
I think with laser sintering would change that.
Not even with that.
I think nano dimension would fight you. I think nano dimension would fight you.
But they're not there now. They still are not making things that I can take and put into a car in a gearbox and say, hey, the tolerance on this is this. They're not there. Yeah, in a laboratory they do some experiments, but they are not there precision wise. I guarantee you.
So metal side, no.
Mm-hmm.
We're talking metal.
Metal side,
yeah. Because like he was talking about Nano DI or Nano Dimension, the company Nano Dimension. Whenever they go to a show, their booth is absolutely hilarious, right?
And what product are they producing that's mass produced?
They do the
printer.
the printer Nano Dimension makes.
But they're mostly used in dentistry.
They're using it in dentistry and small stuff like that.
I can see that.
It's like silicones.
Yeah, but that's different.
Well,
that's
the thing is
but the level of detail.
Yeah.
No. I agree with that 100%. That's totally different.
So, like, they do some watch replacement parts because they can 3D print them where they're like this big. But the thing is, you have to look at them through a microscope to be able to see them because they're printed in that fine of detail. So, that type of stuff is just cool. Sidetrack.
Yeah, I'm just saying that I know from working with these machines.
It's not cheap enough.
And I've seen additive manufacturing. It's not even cheap enough. It's not at the same precision. You can go to any standard and 3D print something and compare it. If I print a block and I machine a block, there is a certain level of precision that you can only get with the technology that we have, which is
are you talking
machining?
Are you talking print and then post process or just print?
Just print.
Print.
Well,
then of course not.
So I'm saying, but when I have a part, I can get it close enough. But when you go to a NIST standard, they have to do some subtractive, even on the 3D printed part.
Yeah.
They would have to do a subtractive process.
That's what I'm saying.
To bring it to tolerance.
Yeah.
But anyway, I'm sorry. I'm just saying.
Gonna be too many.
It will get there. Yeah. I'm just saying it's not there today.
Yeah.
But again, I think we've ran this one, and I hope everybody kind of learns something. A little bit of the joke around having a good time, stuff like that. But we hope everybody got to learn something a little bit more about vertical integration. We want to say thank you to everybody who has, tuned in, who has given us a time of day, and for some of y'all, thank you for tuning into last week to actually making sure I completely sound like I was talking to myself. I highly appreciate that. Felt crazy enough doing it. But, I want to say thank you to the, 2,872 y'all who've actually listened to us. Tuned in to listen. It could be the same person over and over and over again. If it is, please find yourself a hobby.
This could be it.
This could be it, and we appreciate it. But, I want to say thank you. Go take a look at, the website, vulcanara.com. We got some stuff coming there. Go take a look at the YouTube channel, Vulcanara Technology Solutions. If you're listening to us on YouTube, please do me a favor and subscribe to the channel so you can see when we got stuff coming. we got some really cool stuff coming soon. Like I promised, there will be a little bit more of some Showtime coverage. For example, we'll be going to SEMA. We'll be bringing y'all along with us, at least for a little bit. Maybe not everything, but some of the cool stuff we'll show y'all and watch y'all have some fun with us. Some other small little projects we got coming. We're going to be building a robot, building a couple things. Go take a look at the blog, the blog.vulcanara.com, and Printed Heritage and Vulcanara 3D. Do need to work on some more shirts, I promise. But other than that, I say thank you. I really appreciate y'all. Thanks for making it fun, and I'm gonna turn y'all to everybody else.
Yeah, I'd just like to say I appreciate all the support. Appreciate you guys tuning in and listening. We really appreciate any support you guys can give us, and help us with the YouTube algorithm.
Yeah. So yeah, I'm always appreciative. So thank you guys for even listening. We started school back, so it's going to be a bit of a chaotic schedule for me trying to make sure I get things done. But I definitely it's in additive manufacturing, so 3D printing. I'm going to definitely be bringing a lot of my schooling into this. So just want to prepare y'all in advance. But yeah, stay tuned, guys. Take a peek at all the websites and all the social medias, and like and subscribe, guys.
All right, y'all. Y'all have a good one.
Thanks.
Bye. That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoyed the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanara Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.